Hello everybody. My name is Abraham Gonzalez. I uh, I will be presenting my paper today on the relationship between crime and tree canopy in Austin, Texas. And then so basically crime, we all know crime is a commonplace everywhere. There's many things that affect it, uh, many things that don't. So we sort of there's this study, there's the study of criminology, which is studies crime and sort of what causes it. And then there's many theories based off of these factors that criminologists uh, create to sort of facilitate their research and sort of uh, reduce crime. So many research has been done throughout the years around the environment, using the environment to sort of reduce crime and its effect. Throughout my research, I found that trees and tree canopy can have a sort of effect on crime through this concept called community prevention through environmental design. That's basically using having the community sort of get together and clean up the environment around them. So that's one of the approaches to crime. So with that in mind, I intend to sort of assess the relationship, if any, between crime and then trees throughout the area of Austin, Texas, while also using the method to find out where the most disproportionate amounts of crime happen throughout the city. So before that, we share a little bit of the literature around the subject. There's this interesting blog post by Christopher Thomas that highlights the inequality of trees throughout the region. Basically, throughout the history of Austin, there's been a movement to place minority groups towards the eastern part of the region from the interstate. That happened back in the 1920s. So then, and then once the 50s came, there was an industrial movement that also positioned industrial buildings towards the eastern part of the interstate as well. So the Christopher Thomas actually researches this topic and this area and finds that the ecoregion divide significantly shows the inequality of trees marked by the interstate. So, and then he basically determines that more to tackle this problem, we need to, of course, focus more on the Blacklands Prairie part of the region in the city of Austin. And then we move on to the study area, of course. So Travis County is the area of focus. Austin, Texas, being, of course, the main area of Travis County, with the highest population count of almost 1 million in the region. So then we also have the the interstate marking the ecoregion divide that the land has on it. So moving forward, so the data sources I used came from mostly the Austin, Texas Open Data Portal that was used for the crime data points for the current year. Clearing the data only to get the 7 most common types of violent crime in the area for the current year. Tree inventory was also the main data source used. The community tree priority map came from this data portal as well. And then income by household came from the Esri demographics. And then the rest of the data, the reference data from the reference map and the interstate came from of course, the tutorial data we used. So then here are my methods I use to sort of assess the relationship. So of course, heat map symbology was used on crime, as the density of points made it harder to visualize. And then we used the aggregate points for the tree inventory, as it was also the density of the points were too clustered together, so there was a sparse distribution of the points, so they needed to be visualized clearer through aggregation. And then, of course, to combine the crime point data with the polygon features of the community tree priority map and income by household maps, we use the summarize within toolset. So that'll give us the count of points within each census tract for the area. So there's the other summarize within, and then we finally perform the 80-20 Pareto analysis. So that basically theorizes that 80% of incidents happen in only 20% of locations, especially for crime. So that's the best way to figure out the disproportionate amount of crime in an area. So moving on, we find that the results from the execution, that there's definitely a disproportionate amount of crime rates throughout the city, where higher tree priority is determined. There's also higher crime rates among lower income areas throughout Austin, and then the inner city, of course, shows the highest amount of crime, being a more denser area with a higher population. And here's the resultant crime heat map symbology. Of course, the denser areas being shown in reddish, yellowish tone. And of course, the inner city is definitely the more denser part where violent crime happens. And this is the result of the aggregated points model that we executed as well to get the tree inventory aggregated into features, and then combining those features into a incident count map where crime occurs in the area. Of course, the inner city also showing a higher disproportionate amount of crime, within the areas. And now we get into the bivariate maps that symbolize the tree priority score versus the crime. So tree priority was based off of a sum of it was a sum of air pollution, tree canopy, temperature, and mental health. The data authors basically combined all that data and determined a score off of that, with the higher score needing a higher priority for the area, and then the lower score needing the lowest amount of priority. So basically, you see that at the ecoregion divide that Christopher Thomas noted in his blog does prove that that there's an inequality of trees, and it also shows that crime is also highest among those areas, as noted by the interstate. And then once we also factor income, the income versus crime also shows a inequality among the easternmost part of the city, needing more attention brought onto it as well. And of course, we get the findings from the model builder executed with the Pareto analysis. From this, we can gather that the innermost city from Austin is definitely the most disproportionate amount where crime is occurring. So inner city of Austin contains the capital, the downtown area, of course, 6th Street, which is the most notable areas as to why is crime happening, of course. And of course, we can draw that trees definitely do have an effect on crime rates, noted by the bivariate maps that we created. Of course, there are limitations. Not one single method can explain crime. Also, there are definitely way too many factors that cause crime as well. So moving forward, of course, research on the topic should focus on other elements of crime, causation, and also other areas of interest with different data sets for that area. And that will be it.